Please, when you join, can you kindly mute so that we'll have a clear discussion. I could get feedback from some of you. Barak, Hafiz, mute yourself, okay? All right, so if a thermometer reads the freezing point of water as 20 degrees Celsius and the boiling point as 150, how much does the thermometer read when the actual temperature is 60? Then a scientist designed a temperature scale to be used in space with its ice point reading 450 RA. RA is a Rankine thermometer, so that's the unit. Rankine thermometer scale. As I said, we have other thermometer scales, but what is common to us are these three. In US, for instance, they use the Fahrenheit scale. And the steam point is 672. Derive a relationship between the scale and the Celsius scale. Then B, what will a temperature of 115 degrees Celsius read on this scale? Question 2 is one of Nigerian physics question. I saw that in physics, one of the year's physics paper. All right. Now looking at the solutions forwarded to me, I must say that most of you did very well. Yes. Most of you were able to do that. So you just create a scale. Question 1. We are told that the scale is such that its steam point, freezing point is 20. Then the ice point, the steam point is 150. Then we compare it to the Celsius scale, the centigrade scale, which we already have. Its steam point is 100, and then the freezing point is 0. Now, when the actual reading, the actual is what we have, is 60. What will be that corresponding reading on this scale whose values or 2 points are this? So what will be the equivalent or the equivalent temperature? That's the whole question. So just as we've been doing for any 2 thermometer scales, if you take, let's assume this is T minus the lower fixed point divided by upper fixed point minus the initial fixed, lower fixed point. Please, it can also be the other way around. Okay, I can also decide to bring 150 minus 20 as a numerator, and yes. What matters is that when comparing it with the other one, you shouldn't turn. You must also follow the same order. So here too, it must be 60 minus 0 on 100 minus 0. The moment you change the order, then you are inviting trouble for your own self. So we have T minus 20 on 130, which is equal to 6 on 10. Of course, 60 over 100 can be broken down to 6 on 10, which I have done. Then, because we are looking for T, we cross multiply, and we have 6 on 10 times 130. Yamiani, can you mute yourself? T is therefore equal to, what is 6 by 13? That's 78, right?
Yes, please.
So 78 plus 20, and that is 98 degrees Celsius. Simply, that's it. And most of you got this correct. And then the common mistake I also saw was that some of you use this actual temperature of 60 degrees, whose equivalent is to be determined here. It was interchanged. Okay, Saki.
I don't get the solution.
Oh, Saki, the same method as we've been doing. Okay, you compare this to this. We are looking for the equivalence of 60 on our scale whose initial ice point is 20, steam point is 150. So for any two scales, this ratio must be the same. That's why, if you recall, when you compared Celsius to the Fahrenheit scale, 0, 100, and we're trying to derive the connection between them, 32 and 212. If we have a temperature of TC on the Celsius scale, what will be its equivalent on the Fahrenheit scale? So that's exactly what we did. And we saw that for any two scales, if you take upper first point minus lower first point divided by the unknown temperature TC minus the lower fixed point, it must be equal to 212 minus 32 on TF minus 32. Okay, so we are basically using the same method we used to derive the connection between two temperature scales. Okay, so 60 degrees Celsius, which is the actual temperature, connects to an unknown temperature of T on this scale. So if we subtract lower fixed point from this unknown temperature, T minus 20, divided by upper fixed point minus lower fixed point, it must be equal to the same thing with the other scale, 60 minus 0 over 100 minus 0. So when we arranged and then determined the value of T, that's how come we got 98 degrees Celsius. So Saki, it isn't anything different from what we've already been doing. Are you okay? Saki, are you okay?
Yes, sir.
Nana Kwame.
Sir, so assuming that you are given a question like this, is it necessary to draw the scale?
Oh, it isn't so necessary, but it will help you make your analysis well. So it will add more clarity to whatever you are doing. But it isn't, if you understand what you are doing, it isn't also by force. Are you fine?
Yes, sir.
Okay. Then question 2. A scientist, so we are going to use even the same method to solve question 2. A scientist designed a temperature scale to be used in space with its ice point. So we have, and Safo, look at this one. Here, if you don't draw it, you can only be able to derive the relationship when, yes, you understand the concept so well, but drawing it would also help you. Okay, so this new scale, space scale, we are told its ice point is 450. So 450 RA, and then its steam point is 672 RA. So supposing we are looking for a relationship between this and the Celsius scale. So let any unknown temperature be T, maybe R. Then compared to the Celsius scale, whose lower fixed point 0 degrees Celsius, 100 degrees Celsius. And this is TC. Okay, C for Celsius, R for Rankine. So we can then use this to derive that relationship. For any two temperature scales, if I subtract lower fixed point from upper fixed point, and then divide it by this ratio, T, the unknown temperature. Please let your R be a subscript. It can even be T, okay, but just to distinguish R from C, the reason for which I have the subscript there. So please note that it is a subscript. It is a subscript, okay? So TR minus 450. This must be equal to the same 100 minus 0 over TC minus 0. So what will be the value of the numerator? 672 minus 450. Yes. Quick one, quick one. 672 minus 450. Blessing and Co. Blessing, Michelle, Michaela.
222.
200
22.
Okay. Divided by T subscript R minus 450. Then this we equate it to 100 over TC. And then we cross multiply. 2 TC is equal to 100 TR minus 450. I saw some of you doing wonderful things. Yes. By dividing through by 100. Yes. You let me finish this and talk about what I. So 100 will go into 100. So we have 2.22 TC is equal to TR minus 450. Therefore, TR, T subscript R, is equal to 2.22 TC plus 450. Please, whenever you are asked to derive an equation, let your equation be simple as possible. Because I saw some of you, a whole fraction, no. Okay, even though you got that right, but in the event of deriving an expression, let your equation be as simple as possible in that linear form, not fractional form. All right. Yes, the other thing you can also do is that you can also, to sort of talk about ratio in change in temperature, then you could have also left your answer as TR is equal to 222 over 100 TC plus 450. Okay, but to you have it as a bigger fraction where the numerator, everything is divided. In fact, it was a bit scary to me. So next time, let your fractions be as simple as possible. So this will be that relationship between the space scale and the Celsius scale. And you must be able to use the same idea to also derive a relationship between this and then Kelvin, Fahrenheit. So at your free time, be exploring. Just be exploring, okay? Okay, because you are learning, try other things. Okay, let me use the same thing to create that relationship. Then you also look at change in temperature and all that. Is there any question here? No question. Then B, what will a temperature of 115 degrees Celsius read on this scale? So here I'm giving a temperature on the Celsius scale. They say it is 115 degrees Celsius. What will be its equivalent on this new temperature scale? So once you have the relationship, you are good to go. So TR will be equal to 2.22 times 115 plus 450. And class, what is 2.22 by 115? 2.22 times 115. Anybody? Lesson. Just bless me. Hey, where are you? Class, where are you?
Sir,
Listen, I'm listening.
sir, please, it's 225.3.
Okay, so 2,
Oh, it's going to be
5.
Sir, no, it's 255. Sorry,
Okay,
255.3.
this plus 450. I have put them together for me.
Sir, please, it's 705.3.
So 705.3 Rankine
RA.
array. That will be the equivalent. So simple, isn't it? Class, isn't it simple? So at your free time, okay, a follow-up question. Can you help me determine the change in temperature between this and the Celsius scale? Change in temperature. Kopama, change in temperature between this temperature scale and the Celsius scale. A quick follow-up question. Change in temperature. We saw that for Celsius Kelvin, the change in temperature is 1:1, meaning 10 degree Celsius change in temperature on the Celsius scale is equal to 10 Kelvin change in temperature. Then on Celsius and Fahrenheit, the ratio is 5:9. What about this temperature scale and the Celsius scale? Change in temperature. Is somebody true? If you manage to finish, let me see you whilst I take attendance. Kopama. Hello, Kopama. Hey, is he gone? Augustine, are you through? Hello, Augustine. Class, can you hear me?
Yes, please.
I'm wondering why those whose names are mentioned are not responding. So, Anita, what's your answer to the change in temperature? Anita,
Yes, sir.
I'm asking if you are true.
No, please.
Morris,
Yes, sir.
how far?
Please, I'm good.
How far with the work? I mean,
It's okay, sir.
so are you true?
Yes, please.
What's your answer?
Please give me a moment. I'm coming. I'm still on it.
Okay. Okay, then let me hear from okay. Yasmin, Alvin, Blessing, what's your answer?
Sir, please, I got 2.22.
2.22.
Yes.
What's the ratio between Celsius and this scale?
Say between Celsius and this scale. I thought you said between this scale and Celsius.
Okay, this scale and Celsius.
It's 672 minus 450 all over 100 minus 0.
Okay, we shall see. So let's go through it for the sake of time, and then what we are also left to quickly go through. This I'm coming in. All right, so how do we determine the change in temperature between this scale and the Celsius scale? So change in temperature TR, delta TR over delta TC. So if R is coming up and TC is a denominator, then it is between this scale and Celsius. If it is delta TC over delta TR, then it is Celsius against this scale. Okay, so note how it works. Then in determining the change in temperature, you subtract the lower fixed point from the upper fixed point. So 672 minus 450 divided by 100 minus 0. What is 672 minus 450? Is that 222? Yes. So
Yes,
2,
sir.
2, 2 over 100. This we can also break it down as 111 over what? 111 over what?
50.
50.
Yes. So the ratio is actually 111 is to 50. Okay. If it is TR over TC, delta TC, then it can be 222 over 100 or 111 over 50. And if it is delta TC over delta TR, then it will be the other way around, 50 over 111, which is the same as 100 over 222. So please note the difference between changing temperature and converting one temperature to the other using the scale. So please, this is how it goes. Any question? Blessing, is there any question?
No, please.
So if we have a change in temperature of 100 degrees Celsius, what will be the corresponding change in temperature on this scale? Yes. We have a change in temperature of 100 degrees Celsius. What will be the corresponding temperature on this Rankine scale? Start work. Asada, I'll be interested in your answer, so do it and share it with us. But the rest of you must also do it. Asada, can you hear me?
Can you come again with the question?
I've
Yes,
given you
please.
a change in temperature of 100 degrees Celsius on the Celsius scale. What will be its corresponding change in temperature on the Rankine scale? Asada, get ready to stop work. Okay, if any one of you has finished, please share what you have with us. If any one of you is true, a change in temperature of 100 degrees Celsius, what will be its corresponding change on this scale? Anybody? Ashima,
Yes, sir.
what's your answer?
Sir, please, I'm not done.
Oh, 21.
Yes, sir.
How far?
Sir, please, I had 672 degrees Celsius. No, sorry. 672 Rankine.
Okay, so RA. Gideon.
So we have 222 anchor.
400.
Yeah, no, 222.
Okay. Then lastly, let me call John Jermaine. JJ.
Sir,
What's your answer?
Sir, please, 672 ranking.
672.
Yes, sir.
You had the same value as okay, let's see. So here, this is what we are applying. Delta TC over delta TR, or the other way around, we got 222 over 100, or 100 over 222. So this is what you use. So delta TR over delta TC. Okay, is equal to 222 over 100. Or it's a lesser fractional form. The choice is yours. So I'm giving a change in temperature of 100 to find the corresponding change on the Rankine scale. So this is 222 over 100. Also the same as 2.22 times delta TC. And what is delta TC? We have 222 over 100 times 100. This and this will cancel. And the change in temperature must be 222 Rankine. So the second answer, 222, is correct. Okay. Please, try to understand the difference between change in temperature and. So all that we are saying is that for change in temperature, the ratio is, or the decimal value of the ratio is 2.222. Now, that does not mean that 100 degrees Celsius is equal to 222 Rankine. I hope you know this. That does not mean that 100 degrees Celsius is equal to 222 Rankine. But it happens in terms of change in temperature, not conversion. If I want to convert 100 degrees Celsius to this temperature, this is what I use. The first equation we derived, and we saw that as TR is equal to 2.22 TC plus 450. So if I'm giving 100 degrees Celsius to convert it to have the corresponding value on this scale, then it becomes 2.22 times 100 plus 450. And I think 672, right? So get the difference between change in temperature and this. Please, is that okay? Class, is that okay? If you have any question. Frank, are you here? Frank Osei? Okay. Silence means absent. Joshua.
Sir, please, the Rankine formula you just stated right now, it is like it is a formula.
Yes, it's a formula we've just derived depending on the information on the other scale given to us. So all that you need is that they must give you the lower fixed point, the upper fixed point, and you can use this to derive that relationship it has with other scales. So it isn't a fixed formula because you can always derive it. It basically depends on the lower fixed point or the upper fixed point and the upper fixed point of another temperature scale. So when they give you that, you can always derive it. Are you okay?
Okay, sir. Yeah. Okay, sir. So this one was the relationship between the Celsius.
Yes, it has with the Celsius.
Okay.
And remember, I asked you to do it for yourself, its relationship with the other temperature scales, because you know the lower fixed point and upper fixed point of the other scales too. Are you okay?
Yes, sir.
All right. Yeah, there is another hand. You're welcome. Please, if your hand is up, go ahead with your question.
So, please, so we are disconnected for a while. So, which one is the actual answer?
No, you see, your first question was about determining the change in temperature. And the change in temperature, we've just seen that a change in temperature of 100 degrees Celsius will be equal to a change in temperature of 222 Rankine, which we earlier solved. Are you okay? But if I'm giving 100 degrees Celsius to convert it to Rankine, we realize that that will be 672 Rankine. Gideon, are you okay?
Yes, sir. Please, thank you.
All right. Now let's look at where we have an ungraduated scale and there is maybe if the change in the length of liquid in a capillary tube, if we look at that as a thermometric property, assuming we have a thermometer that is ungraduated, so for ungraduated scales, for graduated scales, we are only considering the situation where we have maybe one scale, Celsius scale, 0 degrees Celsius, 100 degrees Celsius, and we just saw that this is also known as the centigrade because this fundamental interval is divided into 100 equal parts. If it's about the other one, Kelvin scale, ice point 273 Kelvin, steam point 373. Yes, Kelvin. This interval is also divided into 100 equal parts. So this is graduated because of these marks, this equal division. And supposing we have a thermometer that is ungraduated, okay, we do not have this. All that we have is that we have the length of mercury at, we are told when we compare it to Celsius scale, at 100 degrees, 0 degrees Celsius, we have length of mercury of maybe 5 centimeters. Then at 100 degrees Celsius, we have a length of mercury of, let me use variables before we come to numbers. So at 0 degrees Celsius, the length of mercury is X. At 100 degrees Celsius, the length of mercury is Y centimeter. The question is, what will be the corresponding temperature at an unknown length of maybe this. Okay, so the rule is that at 0 x1, at 100 x2. If the length changes to x, what will be that corresponding temperature to this length of mercury? So when we connect, there's the idea at 0 degrees Celsius, this is the corresponding length of mercury within the tube. When the temperature changes to 100, we have x2 length. When it is x, how do we calculate the temperature that correspond to this length of mercury within the tube? Please, are we okay? So how to calculate this is the same as what we've done before. For any temperature scale, if we subtract that temperature, theta minus the lower fixed point, divided by upper fixed point minus the lower fixed point, it must be equal to that corresponding length of mercury. So x minus x1 over x2 minus x1. With this, we can easily determine the temperature theta. So theta in this case would be equal to x1 minus x1, x minus x1 over x2 minus x1 times 100 degrees Celsius. That is comparing this ungraduated to the Celsius scale. Now, if it is Kelvin, in modern thermometry, instead of the upper fixed point and then the lower fixed point, okay, only the reference point, which is the triple point of water, and the triple point of water is the 273. In fact, the actual value is 273.16 Kelvin, but it is often summarized to 273. So, in modern thermometers, instead of for Kelvin scale, instead of bringing 373, which is the steam point, reference is made to the triple point 273 Kelvin, and rather the absolute zero K in most times. So if it has to do with the modern Kelvin scale, you wouldn't find the 373, but rather they compare the lower fixed point, which is the triple point. The triple point is the temperature where ice, water, and then vapor exist in equilibrium. Okay, ice, water, and vapor exist in equilibrium. So in most cases, if it has to do with the Kelvin scale, this is what you find. The comparison is rather, so in this case, the unknown will be here, TK. So if it has to do with this, you realize, or you see TK minus 0K, or 0 over 273 minus 0. so that TK over 273 will be equal to x minus x1 over x2 minus x1. Therefore, TK, that corresponding temperature, will be equal to x minus x1 over x2 minus x1 times 273 Kelvin. Sometimes too, because at 0K, okay, this is the point where objects have zero kinetic energy. There wouldn't be any thermometric property at 0K, meaning at 0K, objects of substances have zero kinetic energy. So because there is no energy, there wouldn't be change in the length of the mercury, volume, pressure, and so on and so forth. So this value of x1, which goes with 0K, will not be there because at 0K, substances have zero kinetic energy. So in some situations, you will see TK to be equal to x over x2 times 273 Kelvin. Choosing this one or this one actually depends on how a question is framed. Okay, it can be framed in such a way that at 0K, there is no thermometric property exhibited. So if it is length, it is 0. If it is volume, is 0. Pressure is 0. So there wouldn't be any value for x1. x1 will be treated as 0. If this is the case, then you go with this. If a value is given at 0K, then you treat it. You treat the question using this relation. Please, is there any question? We will be solving similar questions. Gideon.
So for the second formula for TK, all factors must be constant, or so is that what you're saying?
This second one, all that I'm saying is that at 0K, materials have zero kinetic energy. If there is zero kinetic energy, then it means there wouldn't be any change in their physical properties. So if it's the thermometric substance is about change in the length of a liquid, there wouldn't be any change in the length at this temperature. So at x1, it's more or less like equal to 0 because there wouldn't be any change at 0K. That is what I'm saying. But you can also, in fact, you can also learn it using this, so that depending on how the question is created, you can decide to either use this or use x1 or ignore. Are you okay?
Yes, sir.
Are you okay? All right. So
yes, sir. Thank you.
okay, let's look at how we can apply this to a question. Please, I'm reading. A thermometer is found to indicate 90 degrees Celsius, at the upper fixed point and 5 degrees Celsius at the lower fixed point.
So please, can you come again?
A thermometer is found to indicate 90 degrees Celsius at the upper fixed point. Yeah, John Jermaine, JJ, mute yourself. A thermometer is found to indicate 90 degrees Celsius at the upper fixed point and 5 degrees Celsius at the lower fixed point. So upper fixed point, it indicates 90. Lower fixed point, it indicates 5. Degrees Celsius. If the temperature indicated by the thermometer is 30 degrees, if the temperature indicated by the thermometer is 30 degrees, so if theta is equal to 30 degrees Celsius, calculate the length of the mercury thread, or calculate the length of the mercury above the lower fixed point. Calculate the length of the mercury above the lower fixed point. Calculate the length of the mercury above the lower fixed point. So this thermometer is such that its lower fixed point is 5 degrees Celsius. Upper fixed point, 90 degrees Celsius. And we are told that at 30 degrees Celsius, what will be the length of the mercury above the upper fixed point? So if we compare it to length, at 5 degrees Celsius, x naught. At 90 degrees Celsius, this is x2. At 30, let's assume is x1. So you are actually looking for x1. Looking at what we've discussed, what we initially discussed, at 0, lower fixed point 0, upper fixed point 100. And this is divided into 100 equal divisions, or 100 divisions, the centigrade scale. And so if we have x naught and then x2, x1 will be that corresponding temperature. X1 will be that length of mercury, which will correspond to this temperature of 30. But in this case, the lower fixed point, upper fixed point are different from the Celsius scale. So what will be that corresponding length of mercury, which will commensurate a temperature of 30? That is the question. So about 3 minutes to try, think through it, then we'll all discuss afterwards, okay? 3 minutes. Are we through? Abena, Alitia, Yasmin, Alexander, Alvin, Daisy, hey Daisy, Kingsley, Kenneth, Zaratu, Usu Ansanja, Ose Usu Janelle, Paddy. Okay, so let's discuss this one. So if we happen to be given lower fixed point of 100, 0, upper fixed point of 100, then 30 degrees Celsius will be equal to 30 centimeter length of mercury. Class, are you with me? Hello, class,
Yes,
are you
please.
there?
Yes, please.
So if it is 0 lower fixed point, 100 upper fixed point, then this temperature of 30 would be equal to 30 centimeter length of mercury, because here from 0 to 100, it is divided into 100 equal parts. So 1 centimeter is to 1 degree Celsius. But in this case, the lower fixed point is 5. Upper fixed point is 90. So it cannot be 1 degree to 1 centimeter. So the best way we can solve this is that, okay, then if the upper fixed point is 90, lower fixed point is 5, then the fundamental interval, which is the distance or the interval between lower fixed point and upper fixed point, is equal to 90 minus 5. So the whole length will be 90 minus 5, which is 85 centimeter. So x2 from the lower fixed point to x2 is 85 centimeter. So if x2 is 85 centimeter, then 30 minus 5 over 90 minus 5 must be equal to x1, which we are looking for, okay, minus 0 over x2, which is 85 minus 0. Therefore, what will be the value of x1? From what you've done, what will be the value of x1? Hello, class, I'm listening. What will be the value of x1? Class, can you hear me?
Yes, please.
I'm asking what will be the value of x1? Yes, Gideon.
So the x1 is 25.
So, yes, x1 is the distance, okay, from the lower fixed point. So 25 over 85 is equal to x1 over 85. And x1 will be equal to 25 centimeter. So this is the value of the length of the mercury thread above the lower fixed point. Please, are we okay? Because I'm going to give you another question. Blessing.
Sir, please, can you explain it again?
Okay. Yes, is there any other question?
Yes, sir. Sir,
I'm
please,
listening.
I don't understand where you got the x1 minus 0 over 85 minus 0. Because my own, I did it x2 minus x0.
Okay, I get your question. Okay, so let me explain it again. Our lower fixed point temperature is 5 degrees. Upper fixed point temperature is 90. Meaning at 5 degrees Celsius, the length of the mercury is x naught. Okay. At 90 degrees Celsius, the length of the mercury above the lower fixed point is x2. So I'm looking for the length of the mercury above the upper fixed point at this temperature of 30. And that is what I've made it, or I've represented as x1. So x naught is the length of the mercury at 5. x2 is the length of the mercury at 90. x1 is the length of the mercury at 30. Joshua, are you okay?
Yes, sir.
Good. Then let's come to the calculation. So all that I need is that length of the mercury which corresponds to the temperature of 30. So as we have always been doing, it can be 90 upper fixed point minus lower fixed point divided by 30 minus 5. Are we okay with this? Blessing, Michaela, and Joshua, are you okay with what I've done so far?
Yes, sir.
All right. We equate it to the length. So 90 minus 5 must also go with their corresponding length. x2 minus x naught divided by x1. Don't forget x1 represents the temperature at temperature 30 minus x naught. Joshua, are you okay?
Yes, sir.
All right. So this is 85 over 25 is equal to, what is x2? x2, we realize that x2 would be equal to 90 minus 5. So 90 minus 5. Oh, okay, I get your question. I get your question. So x2 is actually 85. So let me indicate it right away. Instead of 90 minus 5. 85, okay, divided by x1, which we are looking for. Don't forget, in terms of distance, this will go with 0 because it's the difference between this and this. So from here to here will be the same as 85. That is how come we are representing x2 by 85. So clearly, x1, x0 is 0. Please, are we okay? Are we okay?
Yes, sir.
So if x1 is 0, if x0 is 0, find x1. x1 therefore would be equal to 85 on 85 times 25, which is 25 centimeter, meaning that this temperature of 30 degrees will be equal to 25 centimeter of mercury above the lower fixed point. Blessing, are you okay? Hello, Blessing, are you okay? Because I'm going to give you another one to try. Okay, so I'm reading. The distance between the upper fixed point and the lower fixed point of a thermometer is 25 centimeter. The distance between the upper fixed point and the lower fixed point is 25 centimeter. Is 25 centimeter. What temperature in degrees Celsius? What temperature in degrees Celsius is recorded? What temperature in degrees Celsius is recorded when the mercury thread is 10 centimeter? When the mercury thread is 10 centimeter above the lower fixed point, above the lower fixed point. The distance between the upper fixed point and the lower fixed point of a thermometer is 25 centimeter. What temperature in degrees Celsius is recorded when the mercury thread is 10 centimeter above the lower fixed point or the ice point? What temperature in degrees Celsius? So note that. What temperature in degrees Celsius? So there can be a question where the temperature will be in other scale as well, Kelvin or that. What temperature in degrees Celsius is recorded when the mercury thread is 10 centimeter above the lower fixed point or the ice point? So let me update the attendance whilst you attempt the question. This shouldn't take you more than 3 minutes. Or even Brella students, it must be less than 1 minute. Gideon, Yasmin. Yes, let me hear from Gideon, Yasmin.
Sir, please, X is 40 degrees Celsius.
40. Yasmin.
I also had 40 degrees Celsius.
You also got 40. Blessing.
Sir, please, I was going to tell you I don't understand.
Come again.
I don't understand.
But did you attempt it?
So you just
Listen,
give us like, sir.
did you attempt it?
Sir, what
Eh?
a question.
But
Sir,
you
I
didn't
did try
attempt.
to. Sir, I did. I did try to attempt it, but then
Mm-hmm.
I didn't, before I could even finish thinking through it, then you started asking for your answers. And then
Okay,
I
then
don't,
let me give you the enough time to look through.
say
Okay.
no, say no, say no,
Mm-hmm. No, we will discuss
say,
it. We will discuss it.
say,
Mm-hmm.
say
Bless, I'm
yes. But
listening.
then I was going to tell you I don't understand from when you were calling my name. But then there was something wrong with my mic. And then after my mic came back, it started working.
Mm,
You stopped calling my name and you didn't mind me anymore.
Mate. Mate, we will discuss it. Don't worry. Okay. All right. Echo.
Sir, please, I got theta is equal to 1,000/25, which gave
Thousand.
me theta
Mm-hmm.
is equal to 40 degrees Celsius.
Okay. So I have three of you getting 40. Yes, more answers. More answers. Martin and the rest of you. Yamiani, Ella, Quintiwa, and the rest of you. Let me hear from you. Vanessa, Zaratu, Janelle, share your answers with us. Ablina, okay. So let's discuss for the sake of those of us who are not so clear with what we are doing. But it's pretty simple. Pay attention. You understand it. Okay, so this question is saying that the distance between the upper fixed point and the lower fixed point of a thermometer is 25. So let's put that into drawing. Blessing, are you there?
Yes, yes.
What about Michaela? Is she also
Michaela is
around?
present.
Sir, please, I'm here.
Okay. So let's take our time to redraw the whole thing. Perhaps if we would revisit the previous questions, that will still help. At least we are all interested in understanding and then moving on. So the distance between the upper fixed point and the lower fixed point, we are told is 25. And it's about the Celsius in degrees Celsius. So what it means is that we are comparing the length of the mercury to these two temperature points on the thermometer. So 100, 0 for lower fixed point, 100 for upper fixed point. And the distance between them we are told is 25. So it means that X naught is a reference point 0. X2 must be 25 centimeter because the distance between lower fixed point and upper fixed point must be 25. So in between, we must have a total distance of 25. Listen, are you okay?
Yes.
So if we have length of mercury, which is 10 centimeter above the lower fixed point. So assuming this is x1. X1, we are told this distance is 10 centimeter. What will be that corresponding temperature? Okay, so x1 is 25, x2 is 10, sorry, x1 is 10 and x2 is 25. Get that corresponding temperature. Let's represent this by theta, the temperature by theta. So theta minus 0 must be or divided by 100 minus 0. This is with respect to the temperatures. We equate it to the difference in the length. Ten minus 0 over 25 minus 0. Please, are we okay here? And I'm bringing this 0 because for every measurement, there must be a reference point where measurement is taken from. Okay, that is why I'm indicating the reference, meaning we are all measuring from that point. Okay. So theta over 100 is equal to 10 over 25. And this ratio is even will be equal to 2 over 5. So let's make theta the subject. Theta would therefore be equal to 100 times 2 over 5. 5 goes into 100, 20. 20 times 2, we have 40 degrees Celsius. What it basically means is that this length of mercury, 10 centimeter above the lower fixed point, is equal to a temperature of 40 degrees Celsius. Please, are we okay?
Yes, please.
Michaela and Blessing, are you okay?
Sir, please, I'm okay.
All right.
Yes.
Another question. Another question. This one, I'll just keep quiet for you people to try and suffer. Then I later help. A thermometer is found to indicate negative negative 0.5 at the lower fixed point. Negative 0.5 centimeter at the lower fixed point. And 90.5 centimeter and 90.5 centimeter at the upper fixed point. At the upper fixed point. If the length of the mercury thread is 60 centimeter, so if we have length of mercury thread to be 60 centimeter. Find the temperature.
Sir, please, I can't hear you.
Okay, I'm starting. A thermometer is found. Is it better now?
Yes, please.
A thermometer is found to indicate negative 0.5 centimeter at the lower fixed point. At the lower fixed point and 90.5 centimeter at the upper fixed point. At the upper fixed point. If the length of the mercury thread is 60 centimeter, if the length of the mercury thread is 60 centimeter, find the temperature recorded by the thermometer. 1. In degrees Celsius. 1 in degrees Celsius. And 2 in Kelvin. Find the temperature recorded by the thermometer. 1 in degrees Celsius and 2 in Kelvin. So start work. I think 6 minutes will do. 6 minutes. Are we true? Blessing, are we true?
Say,
Are you true?
yes.
Michaela,
Hey,
are you also true?
yes, please.
Do we discuss a class? So you can mark
Yes,
whatever. So you can mark, okay? All right. So the difference we have here is that Joshua. Hello, Joshua.
Yeah.
It will do us a lot of good if we are to produce some sketches, okay?
Okay, sir.
So for the Celsius, 0 degrees Celsius, 100 degrees Celsius, then we are told at 0 degrees Celsius, the length of the mercury is minus 0.5. Then the upper fixed point is 90.5. When it is 60, when it is at 60 centimeter, what is the corresponding temperature? So 100 minus 0, then theta minus 0 must be equal to 90.5 minus 0.5 divided by 60 minus 0.5. Okay, so we have 90.5 plus 0.5, which is 91, divided by 60.5. 100 over theta is equal to 91 over 60.5. Theta, therefore, is equal to 100 times 60.5 over 91. What is that corresponding temperature? Class, what is that corresponding temperature?
That's 66.48 degrees Celsius.
66
Point
0.8.
48.
Okay, so approximately 66.5 degrees Celsius. That will be the temperature on the Celsius scale. Then, please, how many of you got this right? Let me see by hands. Okay. In fact, I want to see more hands also. Okay. once. So, all right. So I got eight of you getting it right. Asida, are you there? Asida,
Yes, sir.
did you get it?
No, please. No,
What happened?
please.
What happened? But have you identified where you add?
Yes, sir.
Okay. Then in the other Kelvin absolute temperature, you know, in absolute temperature, we do not consider the other points, but rather make reference to 0K, 273.16. So TK. Now, here at 0K, we were given value. So at 0K, this is minus 0.5 centimeter. And at 273, we are told the length is 90.5. That's the only difference. At 60 centimeter, that is TK. So TK minus 0 over 273 minus 0 is equal to 60 minus 0.5. So plus 0.5 over 90.5, also plus 0.5. So the only difference is that here at 0K, we are giving value. Therefore, TK on 273 would be equal to 60.5 over 91. TK, therefore, is equal to 60.5 over 91 times 273K, which is equal to what? What's the answer? 60.5 over 91 times 273K.
181.5.
181.5
.5.
K. So that will be the corresponding temperature on the absolute temperature scale. Gideon.
So why is the lower fixed point for the Kelvin 0 instead of 273?
Instead of,
So why is the lower fixed point of the Kelvin scale 0?
Gideon, I earlier said that in modern thermometry, especially on the absolute temperature scale, we make reference to the triple point, which is 273, and the absolute 0. So the 0K is more or less like the lower fixed point, and this is the upper fixed point. So that is why we are looking at 0K. Gideon, are you okay?
So please say everywhere we find a question containing or concerning the Kelvin, we should use this lower fixed point 0 and then the upper
Yes,
fixed point 273.
exactly. Because I said in modern thermometry, this is how it is done. For this kind of questions, not conversion. Don't link it to the conversion. With conversion and then the change in temperature, we are still using 273, the triple point as a lower fixed point, and 373. For this kind of calculations, I'll be giving you similar question. And note that here at 0K, materials have zero kinetic energy, so thermometric properties do not show. But here at 0K, we are being given a value. So there are situations where you'll be given a value at 0K or without a value. Here you are given a value which is negative 0.5, and so you must use it as such. Please, if there is any other question, quickly ask, because our time is almost up. Is there any other question? Joshua.
Sir,
Hello.
please, the question we saw previously, I was confused because I saw a different vertical line at the other
Which
scale,
one?
the X.
Which one? Is it this question?
The one it was talking about the mercury thread.
Oh, there were two questions about mercury thread.
Yeah, just this one.
Is it this one where
The one on the
where we got X to be 25 or?
yes, sir, yes, that one.
Okay. So here,
Sir, when
ask your question.
When you are giving the question for the current one, I
Mhm.
thought the 60 was the mercury thread because I was confused.
You see, the whole argument is that when temperature is 0, the length of mercury within the capillary tube is at negative 0.5. And when temperature is at 100, the length of the mercury thread is at 90.5. So when it is at 60 centimeter within the capillary tube, what will be that corresponding temperature above the lower fixed point? So that's all that we are looking for. So
Okay, sir.
using the Celsius, 100 minus 0, upper fixed point minus lower fixed point, divided by this unknown temperature minus the lower fixed point, must be equal to, you do the same to the length. At 100, we have 90.5. At 0, the length of the mercury is 0.5. But don't forget, it's a difference. So 90.5 minus negative, we're giving negative value. That's
Okay,
why
sir.
we had negative minus 0.5 divided by the given length minus the lower fixed point. So it's basically the same principle as we've been using. Are you okay?
Yes, sir.
All right. Class, our time is up. I think we've even gone past it for 3 minutes. So if you have any further question or clarification, you can WhatsApp it to me and I'll respond. I'll give you a trial work as well. Okay, thank you very much for your attention, your contributions and everything. Please continue revising. And I mean, if you have personal issue to contact me. Until then, may the good Lord be with you. Take care of yourselves. And then, bye-bye.
Bye.
Okay.
Bye.
Mm.